Welcome to College Algebra, section 5.3. My name is Gregory Carlson. In the last section, we learned how to use an augmented matrix to solve a system of equations. In this section, we're going to learn something called a determinant, which is a number that has special properties. And we're going to learn a Cramer's rule, which is going to be one more way to solve a system of equations. So first, let's talk about what a determinant is. Determinants really only exist for square matrices. And so as a reminder, a square matrix is one where it has 5 rows and 5 columns, or 2 rows and 2 columns. The number of rows equals the number of columns. So if you have a square matrix like A, B, C, D, just say these are just 4 numbers, A, B, C, and D. If you have a square matrix, you can find the determinant of this square matrix. And that determinant is a special number that's associated with the matrix, and that special number has a lot of special properties. And we're going to look at one of them today, but there's dozens of properties of the determinant, and they're very useful in higher level math. So here's how you represent a determinant. They kind of look like absolute value signs, which is unfortunate, but that's just how it is. So if you see, let's call this matrix capital A, okay? So if this is matrix A, then this is how you would write the determinant of A. And as I said, it kind of looks like absolute value signs. You might also see people write it like this. And so again, that just means the determinant of A, okay? So what is the determinant of A? Well, it's really easy. If this is the matrix, A, B, C, D, then the determinant of that matrix is this number times this number minus this number times this number. And that's it. And by the way, this is only for a 2 by 2 matrix. We'll look at 3 by 3 in a second. So the determinant of A is just this number times this number minus this number times this number. And really, you only just have to be careful with your negative signs. So let's look at an example. What is the determinant of this matrix? Let's call this matrix G. Okay, so in that case, the determinant would be 2 times 8 minus 5 times 6. Okay, and just be careful with your negative signs. Also remember order of operations. So this is multiply first, 16 minus 30. So the determinant of this matrix is negative 14. Just like that. A little easier than what we were doing in the last section. How about the determinant of this matrix? It would be 6 times negative 2 minus negative 4 times 3. Okay, do you agree with me? 6 times negative 2 minus negative 4 times 3. And it's always that way. It's always this times this minus this times this. So negative 12. Negative 4 times 3 is negative 12. So we get 2 pluses. So negative 12 plus 12 is 0. So you can see that sometimes the determinant of a matrix might in fact be 0. All right, let's do this third example. This times this minus this times this. So 3 times 0 minus 2 times negative 5. Here's where you need to be careful with your negative signs. 3 times 0 is 0. Negative 2 times negative 5 is positive 10. So the determinant of that matrix is just 10. And so finding a determinant of a 2 by 2 matrix is pretty straightforward if you're just careful with order of operations and your negative sign. So now let's talk about how to find the determinant of a 3 by 3 matrix, which is a little bit trickier than a 2 by 2. So here is what you want to have in your brain when you're thinking about finding the determinant of a 3 by 3 matrix. Because basically, the determinant of a 3 by 3 matrix is going to be made up of several 2 by 2 determinants. So just know that there's this structure inside of a matrix that goes plus minus plus, minus plus minus, plus minus plus. And so these just keep alternating, plus minus plus minus, plus minus plus minus. So you want to memorize this, the structure inside of the matrix. What we're going to do is we're going to travel across a row, or we're going to travel across a column, and that's going to do the determinant. And so the only way for me to explain this is to just show you an example. So let's find the determinant of this matrix right here, 2, 4, 3, 5, 6, 2, 1, 6, 4. So here's how it works. We're going to take a journey across the top row, okay? And this right here, this little grid right here is going to tell us what the signs are going to be. So do you see how in the top left I have, in fact, let me just write it again on this page. It's plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, so here's how it works. You start with positive 2 because it's a positive and a 2. Now, we're looking at 2, and so here's what you do. You ignore the row that 2 is in, and you ignore the column that 2 is in. And do you see how that gives you a 2 by 2? Now we do the determinant of that 2 by 2. So it's 2 times the determinant of 6264, because you ignore this and you ignore that. Okay? All right, so now we're done with 2. Let's continue our journey. Next we have a 4, and we see that it's minus. So minus 4 times, now we do the determinant. We ignore we're doing 4 now. So we ignore this column, and again, we ignore the top row. Okay, so do you see how that gives me 5, 2, 1, and 4? So that's this one. I know this sounds crazy. 5, 2, 1, and 4. But this determinant is very useful. So again, ignore the column, ignore the row, and that gives you a 2 by 2. 5, 2, 1, 4. Finally, we have a 3 to complete our journey. So this is going to be, we see it's a plus. So plus 3. Now we ignore the top row and ignore the column with the 3 in it, and that gives us 5, 6, 1, 6. There you go. That's what the determinant of this 3 by 3 matrix is going to be. So let's simplify that. So this is going to be 2 times 6 times, now it's just a 2 by 2 determinant. 6 times 4 minus 6 times 2. So 6 times 4 is 24, minus 2 times 6 is 12. Okay, that's a 2 by 2 determinant. Minus 4 times 5 times 4 is 20, minus 1 times 2 is 2. And then finally, plus 3 times 5 times 6 is 30, minus 1 times 6 is 6. So there you go. So I started us off with one that had all positive numbers, because really the only way to make this more difficult is to add a bunch of negatives, which we'll do in a future example. So remember, the determinant is just a number. So let's see, 24 minus 12 is 12. 20 minus 2 is 18. 30 minus 6 is 24. So that's going to equal 2 times 12 is 24. Minus, I think 4 times 18 is 52. 72, actually. So how about 72? And 3 times 24, I think, is 72. Yep. So there you go. So 72 cancels with negative 72. That doesn't always happen. You just basically need to add up all the numbers. So the determinant of this first 3 by 3 matrix is 24. So that's pretty cool. And so hopefully you understand now how to find the determinant of a 3 by 3 matrix. I'm going to go ahead and stop this video here, and we will do example 2 in the next video. Because there's actually a special trick you can do to make this a little easier. I'll see you there.